Well, we've made it to module 10 on our querying with Transact SQL course, and we've covered a lot of ground so far. I hope you've enjoyed the modules you've done so far and you've been keeping up with the labs and getting your hands on with this stuff. In this module, we're going to start moving beyond the basic set-based queries that we've been looking at to query tables to get data out or to insert and update and delete data. And we're going to start looking at actually doing some more extensive programming, writing some procedural logic with Transact SQL. So Jeff, you're going to take the helm on this one, so why don't you tell us what we're going to cover?
Well, we're going to, as you said, we're going to extend what we can typically do with our set-based queries. We're adding in some programming logic, some procedural logic, so we've got some branching and looping. We'll also look at batches, comments. We've covered some of these things already. We've seen a few comments, we've seen some variables, we've seen some table variables already, so we're going to look at those in a bit more detail and how we can pass values to and get values from those. We'll loop through code. We might want to iterate a number of times through some code, and also we'll have a look at stored procedures. Again, we sort of touched on these things, but we'll actually encapsulate our code in the stored procedure at the end as well. So to start off with batches, we've mentioned batches because of losing values in those table variables before. As it says there are sets of commands sent to SQL Server as a unit. So it's sent. We talked about carriage returns in our SQL not really meaning anything, so it could actually be written as one long line. But when we have a go, then that batch is sent, and then there's a go word, and then the next batch is sent. So they are definitively separate. They have functionality in that our variables, we declared a variable, we got values out of a variable, we put values in, got values out, but it didn't work when it was either side of a go, when it was in a different batch. So they are relevant to what we do. Now it mentions in here that uses the go keyword, but it's not a T-SQL command. So this is a little bit odd because it's in T-SQL. We've just typed it in a load of T-SQL we're doing there, and you've got this word go in the middle. Actually what happens is that the client application, so we're using Management Studio a lot, but equally any of the clients we've used in this course, they interpret the go and they send the statement before and then they send the next statement after the word go. So it's actually the client that's doing that. It's not going to run it in the back-end database engine.
So this is just a signal to the client that now it's time to batch up these commands I've given you and send them to the server to be executed.
Yeah, oh, hit a go, right, send everything we've got so far.
Okay.
And then the next bit. So that, and actually when you see that logic, it makes sense how those variables don't carry on through because they're sent as separate things. So some things we saw we can carry on past to go, other things like variables, they don't. Comments. Now comments are really, really useful in my opinion. Myself and Graham both sort of got into companies doing consultancy work and they say, well, my database isn't working properly. Here it is, here's all my scripts that I run against it, here's my procedures, and you look at it and you think, it's really difficult to work out what's going on there. I can't quite see why you've done it. Or the classic is, I have no idea why you've done it that way. You seem to have done that wrong. So the first thing I'm going to do, let's fix that. Then actually you realise, you did it that way because of a reason. It wasn't actually wrong, it was just unusual. Now, if you put a comment in there, say, I've done this, anything that's out of the ordinary, unusual, needs describing, we can put a comment block in there. Two ways of doing it. / and then star we can add, and then everything after that point is a comment block. Now, it could be on one line, it could be on multiple lines. We see there, this is a block of commented code. That whole block is commented out and typically goes green in the client. It does depend on the client you've got. And the other one is just to put 2 dashes in and that will comment out the rest of the line. So if it's just a one line one, quite often just use 2 dashes. But if you want to have a long description of what you're doing, why you've done it, I think that's the key thing, is not the what, it's the why. In terms of someone else coming in and seeing it, if you've done anything unusual, go into why that is. So say, I've done this because of this, and you think, right, okay, I'm not going to correct that, and that's correct. And as it says, so typically they color code them, not necessarily the case, but mostly they get color coded, typically green. And variables. So we touched on them before with our table variables. There can be lots of other things. So in most cases, I'd say they're actually single scalar values, but we can have tables, we can have really anything be stored in a variable. And we have a declare keyword. So we're going to declare a variable, we're going to give it a data type, and then the other thing, question for Graham, so what's going on in there with, so we've got that colour variable and we've got the size variable, but they've got an equals to.
Yeah, so in common with many other programming languages, you can, at the time you declare the variable, you can initialize it with a value, because a variable is just a placeholder for a value that you want to use. You don't have to. You could just declare it and say what data type it is, and then use a set statement later on to actually assign a value to it. But in this case, we're assigning an initial value at the time we declare it.
So we're not fixing it as black large.
No, as its
name
name suggests, it's variable. The value could be varied. Yeah. So later on, you can assign a different value to it.
Okay, so that's example there. Declare two variables, color and size. It begins with an @ symbol, and then using it where we would just use, whether it be a string, whether it be a number, where we would use a value. So we've got a select where the color is equal to @color, size is equal to @size. So we're going to use that variable, remembering not to put a go in between the two, because then it would lose the variable because it would in a separate batch. There we go. So always local to the batch, go out of scope when the batch ends. Now we're going to have a look at using a variable. So starting out, declaring a variable @city, giving it a default value of Toronto, and also we've got a comment in there. So we've got commented out, because I'm going to use that a little bit later, but you can actually see that won't run. I can just go and highlight all of that and it won't run. And then we're going off and we're going to go and find information where the city is equal to that variable. Now when I run this, deliberate mistake in there, and it's saying, well, what is @city? I don't understand what this @city thing is. That's because we've got that go, we've got two batches going on here. The second batch has no idea what the @city variable is. As far as it's concerned, it doesn't exist. So if I remove the go, then we have one batch, run the same thing again, and this time we're getting all the people in Toronto. We can change that variable because we have a set statement in there, so we can also explicitly say I'd like that to be any particular value in here. And if I run it with this one, that would too much, then we have Bellevue selected in there. So we can use that. So basically we can pass values into a query in here. And we'll see at the end of this section when we do store procedures that it's really useful to be able to pass values into code there. Now, a variable is an input in that respect, but it needs to have a value in it. So I supplied one by having it typed in, but equally we can have an output. So we can have a variable which actually receives information. So here we've got declare @result money, and then select @result equal to. So it's a select statement with a little bit extra in there to say, I would like to take the results of that select statement, and they have to fit. I have to have something that's going to go in there. Mm-hmm. Take the result of that select statement and drop it into the @result variable. And that initially is all that will do. So as it stands there, we can run that. It says completed successfully, and that's all it's done. It's put a value in a variable, hasn't done anything with it. And then I'm very simply going to just print it out on screen. Again, part of the same batch to make sure it works. And then it prints the results there. So we can see that I've actually taken a value from data, dropped it into a variable, and in a very simple way, in that case, used it to output. But of course, we could add that into the previous one and looking at our cities and so on. So we can take values from somewhere and supply them to another query somewhere else.
So previously we used set to assign a literal value to the variable. When I was assigning a value, we used set. Effectively, I'm assigning a value to the variable here as well, but the difference is I'm actually getting that value from the results of a query. So it's select the variable equals.
Select, and you can, and there are other ways we can do. We can, as long as we've got the right amount of data. I know that total due is a money data type. I know it's a single value, because if I returned 10 rows or 2 columns, that won't fit in there. So as long as I know it's going to fit, okay, I can supply that value.
So the type has to be compatible with...
Yeah, it's not just going to pick the first row, first column. It will just fail if it can't fit into the variable.
Okay.
We have seen already, we had table variables, and then we can do
Yeah.
a bit more of that with them. Now we're going to have a look at branching our code. So we're going to have a look at a condition, in this case if, and if the condition is true, we'll do one thing, and if it's false, we'll do another. Or actually, to make it even simpler, if it's true, we'll do this thing. So that's the most basic one. We can say if, and then a condition, if that's true, we do something. Then we can add a little bit more to that and have an else, and say, okay, if it's true, do this, else, do something else. Now, these ones in here are quite simplified in that they just have one line of code, one statement. So even though the second one is select star from production product, where color equals that color, it's on 2 lines, it's one single statement. So that's fine. Now, you can also have multiple statements, and if you do, then you need to wrap them up in a begin and an end. So I would typically actually start my blocks, even with only one statement, I tend to wrap them up in a begin and an end, just if I were to add another line later on, it's wrapped up inside that logic within there. So it allows us to do, that's more of that sort of programming idea. We're not just doing things always running straight through everything. We're saying, no, we have a condition, we have a test. And based on that test, we're going to perform some statements. Starting off here, I have a very, very simple test. If yes equals no, print true. Now, we know that yes doesn't equal no, so it doesn't do anything. It's not going to return false. It's just basically saying I have no alternative for it to do. Obviously, if I say if yes equals yes, then our logic evaluates, well, yes equals yes. I say a lot of yeses. And then it evaluates as true. So then it will print it out. So there's not an alternative there. So when we saw it didn't work, it didn't print something else. It just said, okay, I'm not going to do anything then. And that command completed successfully is just saying, look, we didn't have any errors. I didn't do anything really. So now we're going to say something a little bit more complicated. So we're going to say, we're going to do an update in here. And we're going to update the sales product, set discontinued date equals to the current date, where the product ID equals 680. Now there's an if, so that will do its update. If the row count is less than 1, i.e. there were 0 updates, then I would like to say print product was not found. Now I've wrapped that up in a begin and an end. It's unnecessary because it's only one line, but I just like to wrap it up for neatness. And I know if I added another line there, it would still be within that block of that begin end block. And then we have an else, so we have an alternative now. So if the reverse logic, if it's not the case, then product's been updated. So the true is that the row count was less than 1, i.e. you could make the logic the other way around if you wanted to. You could do a greater than 0 and have the logic reversed. But essentially in our case, if it's less than 1, there was no rows, so product was not found. The false is actually that there were, so I want to say product updated. Let's have a look at running that. Let's just get rid of my results for a second. So we'll do the update, and we're basing on product ID 680. So if I execute that, product was updated. Let's try with a different number. So let's try it with product ID 1. Now if I run with this one, product was not found. So we've got logic which checked to see how many rows were affected. Actually, after they'd been affected, it said how many were there 0, was there more than 0? And there is no product ID 1, so that's why it didn't get updated in that situation. The next thing we're going to have a look at is looping. Now we may decide that we need to run through our code multiple times. We can base that number of times on a value we type in. We can base it on a variable that we've populated from a value in a table somewhere. So we can get the value from somewhere. But the idea is looping through. Typically, we're doing set-based operations in SQL Server. So we don't typically want to loop through our data row by row. We want to work on it as a set. It's efficient to work on it as a set. We don't want to go through row 1, then row 2, then row 3, then row 4, then row 5. It's a slow way of doing things. So what we're going to add in is looping logic, but just be wary that the ideal is to work with sets. So what we're going to say here in this example, we've got while at cust ID, so we've declared customer ID, it's an integer, starts off being equal to 1. So while that is less than or equal to 5, and then we have a begin and end block, and in that block we're going to say set at lname, which we've also declared at the beginning, equals last name from sales customer, where the customer ID equals that cust ID value, starting off as 1, then printing out the last name, and then iterating through. So we're going to go through and add 1 each time, so then it will go through and run it against 2, and then it will run it against 3, and then eventually it will get to a point and say, customer ID is not less than or equal to 5, so that condition won't, it will then jump down to after the end, that condition won't evaluate to true. And there it goes, loop will end when the predicate evaluates to false or unknown.
Is there any other way of ending the loop? I mean, if I got halfway through and then for some reason decided to cancel what I was doing,
absolutely. So if we maybe have some sort of test in there, so as we maybe have a lot of code going on in there and say, well, you've been adding 10% to our sales values, and you've decided to do that as many times as there are products in a table, but once you get to a certain value, I want to stop that. So we could say, okay, let's put maybe even a condition in there. We can have conditions inside our loops, and so we can nest these things together. And what you have is two things you can use. You can have break or continue. So we can basically break that code, which basically I want to stop everything, or continue on after that block of code. So we can explicitly do that. So you're going to put a test in there. You wouldn't just drop that in for no reason. You test for something. If that condition is true or it's false, potentially, then you would decide that actually you don't want to continue your code as you were going. Okay. Or you don't want to continue looping rather as you go. Looking at while, similar example, we have a counter. So we declare a counter. We set it to 1 to start off with. While it's less than 5, so let's put less than or equal to 5 because I want to say 5 is okay. We're going to have a loop. Again, really useful, create a begin-end loop. And actually, I like, personally, it doesn't make any difference to SQL Server, but for neatness, to indent everything in that block just makes you aware of, okay, that's what's running, I can see that code. Indentation just makes it easier to read the code in there. It doesn't make any difference at all to the system when it runs it. So what we're going to do is we're going to insert into this demo table a description. That's all it requires. And we're going to put in their values, and it will have the word row, and then it will convert that counter into a varchar. So basically that counter is going to be, that value is going to be supplied. It will say row 1, row 2, row 3, row 4. Then it sets it to itself plus 1, and then it loops back round because it's got a while in there, so it's going to go back round through. As long as that is less than or equal to 5, it will keep going. So if we run that one, making sure we've got the declare as well, it has to be in the same batch as before. And you can see, now, there is a point here. Why is it done 1 row, 1 row, 1 row, 1 row?
Because it's actually doing the insert 5 times. It's not like earlier where we did a set-based operation and you had one insert that inserted multiple rows. This is actually doing multiple insert operations once for each loop.
So if we had a set-based operation that worked on 1,000 rows, would that be the same as having a loop that did 1 row 1,000 times?
No. If you did a set-based operation that inserted 1,000 rows, it would run once and the message returned would be 1,000 rows affected.
But in terms of performance, does it make any difference?
In terms of performance, it would be much more efficient to use the set-based operation than to loop through 1,000 times. Okay,
so set-based is really the way we want to go. So we're not doing this just because we can. It's something because we have a scenario where we need to be able to loop through. We have to avoid that set-based way of working, but the set-based system gives us the efficiency.
I guess it's worth pointing out as well, I mean, the loops that we've looked at here, we're using a number to indicate the number of times we want to loop through. Well, actually, that condition can be anything. It's any condition that could be true or false. So you could actually have a loop where you say, while true, do this, in which case it would keep doing it indefinitely because true is always true. But then somewhere in that loop, you might have another test that checks for something that calls break if a condition happens. So you might have a loop that's always running in the background unless something happens, at which point it breaks out.
And probably because of something it's doing, it's causing a value to go out of range or
exactly,
something unacceptable.
Yeah. So loops can be useful when you don't necessarily know how many times you want to try and do something. You just want to keep trying until a condition means that you stop trying. So typically you don't use it for, doing set-based operations like inserts or updates or those types of things. But you might use it in a case where perhaps you're checking for a specific time, or you're checking until something happens. You want to keep trying to do something and then stop. It's, to be honest, not very common in Transact SQL that you have those types of operations because databases tend to be set-based tasks, but there may well be situations where, you want to iterate an indefinite number of times until a particular condition is true and then stop looping. Yeah.
So we can't know how many times to loop until we do it. And then, or we certainly not in the future with data that might change, we wouldn't know. We can't know until it does it. So just to very quickly, just to run that so we can see row 1, 2, 3, 4, 5, it looped through 5 times, and that you can see it did for those 5 loops. Now you actually could see it before from the rows that it done 5 individual rows. We're now going to look at something a little bit different, which is stored procedures. So we're encapsulating code into a named block of code, if you like, a named object which contains that code. Now we've already done views, so this is a little bit different. Typically, we're using a view in the same way that we'd use a table. So we have a table and a view we use in exactly the same way. We can select from it. And we mentioned there are situations where we can update and there are certain rules. Now, a stored procedure is a little bit different. And typically, you can actually use a stored procedure to output results, but typically we're using them to do a little bit more. So we might be doing some updates, we might be doing some deletes. Here we actually have an example where we do a select. So you can do either of those things. The other thing that's nice about them is they're kind of set up to use variables or parameters, if you like. So you can pass a parameter into the procedure, and then it will run it using that parameter. They also can have an output parameter, so they can return a value as well. So they can actually have a parameter set up and marked as output, and then that is the value they return. So they can return a value as well as having values going in. Right, we're going to create a procedure now, starting with the first part of this before we get into any of the code. We've got a name, create procedure, procedure name, and then you can see in brackets we've got @category ID, so that's a variable we've seen. It's essentially being declared as part of the create procedure. It's an integer and it has a default value of null. So it's just the same way of declaring any variable. We've given it a default, we've given it a data type, we've given it a name. Then we have an as, and then everything after the as is the code essentially we're running. So we have an if in here, got an if statement. If the category ID is null, either because you've passed null or you've passed nothing because it defaults to null, then I would like to select all products. In here we want the product ID, name, color, size, list price of all products. If you supplied a value, so I actually want to create a procedure which has more than one function, so it's a bit more variable. If I supply a value in there, then I would like to query the same table, the product table with the same columns, but this time looking for a product category ID matching the category ID that you supplied when you ran the stored procedure. So if I run all this will do at the moment is create this object. It's not going to actually run any code to do those selects in there. It just creates the object. So all I'm expecting in here is command completed successfully, and that's fine. So to use it, we have an exec statement. Now, I've seen actually some people run stored procedures without exec. So why do we need an exec statement?
So it's typically best practice to have exec or execute as the full version of the thing. They both do the same thing. You don't have to if it's the first statement in the batch. But if there are multiple statements in the batch and one of them is executing a stored procedure, then you have to explicitly say execute or exec.
So if I had a go and then a stored procedure, it would work. But what if I put another line of code in after the go?
Yeah, exactly. So typically, to be honest, when you're executing stored procedures, most commonly you're doing it from a client application. So the code that actually calls it isn't Transact SQL. It's going to be C#, and I'd be using some sort of object to call the stored procedure. But if I am calling a stored procedure from some Transact SQL code, and of course I could call a stored procedure from within a stored procedure, then best practice is, regardless of whether it's the first statement in the batch or not, to use exec or execute to explicitly say, I want to execute this stored procedure.
Okay, so we've got this one. We've got, as we should do, have exec at the beginning. It is optional. I mean, we've said some things are optional and we never bother, like the UTE at the end of execute. Never ever type that. That's 3 letters I don't need to type. But the exec, it's optional, but it does. It's useful. It's clear what you're doing as well. I know you're running a stored procedure because you put exec before it. And so here we go. That's run it against absolutely everything. 295 rows is all the products we have. We didn't pass the parameter, so it did. There was a parameter. The parameter that was passed was null because that was default. So it wasn't that there was no parameter. It defaulted to null. So then we tested for that. We saw that it was null, and we ran it against absolutely every row. This time passing the number 6. Execute that one, and we only have 43 rows because we're doing it against the category 6 in there, so it's filtering using that category ID because we passed that value in. So we've seen a few additional things we can do with SQL to add in some programming logic into SQL code. So that Transact SQL code, we've extended its functionality and we've added to it what we can do. So the use of batches and comments is fairly straightforward. Comments really useful, I think, to document what you're doing. But then we get into things like variables where we can store values and then reuse them later on. We've got the idea of branching, so if and else, and we've got the idea of looping through code. And then finally, the idea we can encapsulate some of our logic and call it as a stored procedure. So it's a really useful thing. If we have a stored procedure, we can do some testing in there, we can make sure everything's right, and then rather than just saying, oh yeah, you can do an insert, we say, no, what you do is you call this stored procedure and you supply the values there. Then I can test what you're doing before it actually goes out and runs it against the database to make sure. So stored procedure is very useful. And as with views, really useful because we can have security. I can allow you to run a stored procedure, but not actually update the table directly.
And you can learn more about stored procedures on some of the other courses that we have where we talk about implementing a database. There's much, much more to it than we covered in this course, but we did want to kind of show you how to encapsulate the Transact SQL logic that you've created in some kind of reusable procedure. So hopefully, once again, you've found this module useful. We really have moved a long way since the very first module with our basic select statements to the point where we're now capable of building fairly sophisticated sets of logical steps and procedures using Transact SQL. Do have a go at the lab for this module. Have a go at using the various different techniques we've talked about in here to write some programmatic logic in your Transact SQL. And when you have completed the lab and you're ready to move on, join us for what will be the final module in this course, which is about error handling and transactions. So look forward to seeing you for that one.